Hello, so I'm back again with another quick data analysis video, still focusing on data visualization. So in this particular video, what I'm going to do is show you how to use Seaborn's facet grid method. So this is a really useful plotting method if you want to create what we'd call small multiples. So these are kind of where you have multiple small plots next to each other or in the shaped in the like a grid, rows and columns, where the groups represent some sort of categorical variable which has been separated over individual plots, over different plots. So it can be quite a useful way to kind of visualize data or trends in data by setting different groups side by side next to each other. Okay, so as I said, it's I'm not going to use matplotlib beyond the functionality that Seaborn makes use of in this video. It's a method that you can use in Seaborn, and as you know from some of the previous videos, if you've watched any of them, Seaborn's kind of quite versatile and it makes it easy to create really good quality plots. So I'm going to start by running this first cell here and importing some software libraries. I'm importing pandas as PD, numpy as MP in case we need them. We possibly won't because I'm going to use a data set that's already part of the Seaborn library. I'm going to import matplotlib.pyplot as PLT and Seaborn as SNS. I'm giving them the usual kind of nicknames that people give them by convention to make it easy to call them. All right, so the data I'm going to use is a data about penguins, which is contained within, it's sort of a sample set of data contained within the Seaborn software library. And what I'm going to do is I'm going to save it as an object, data frame object, pandas data frame object called penguins. I'm using sns.load underscore dataset, and the name of the data set, I'm passing it in these double quotes as a string is penguins, and then I'll call the head using the .head method, and you can see there we got this nice pandas data frame, and it's I'm not sure what the source of the data is, but you've got like species, island, so penguins on kind of some Antarctic islands I'm assuming, and then a series of measurements including the length of the bill, depth of the bill, length of the flipper, their body mass, and then sex, male or female. Okay, so kind of quite useful. Some scale variables here that can be plotted, and some categorical variables such as species, island, sex that can also be usefully plotted. Okay, so I'm gonna, just as a personal preference, I'm gonna use the sets underscore style argument. I'm going to set that as dark green because I kind of like the appearance of those plots. And in order to call the facet grid and to use this facet grid method, like with most Seaborn plotting methods, you call Seaborn SNS in this case, and then use dot whatever the method is. In this case, it's facet grid, but notice the syntax is slightly different to a lot of others. It's got like a capital F and a capital G, so there's a couple of letters capitalized there, so it's slightly different. And then within parentheses for that method, I'm passing the penguins data frame object, and I'm also giving this argument col equals island. So what I'm doing is I'm using this island variable here, which has 3 levels. We'll see what they are in a second. I can't remember the names of all 3. One of them's Torgerson, as you can see there. So it'll create, what this will do is create 3 separate plots based on the fact that there are 3 categories within island. There are 3 different islands, and that will be plots next to each other. So 3 columns essentially. And then what I'm doing is, I'm then adding this .map method at the end, and the arguments I'm passing to that is that I want a Seaborn hist plot, and I'm telling it to create a hist plot of the bill length. So let me run this, and you kind of, once you can see it, I'll make it clearer what these things are doing. So we asked for the facet grid to be split based on the island variable, which has 3 levels, and each island represents its own column. So what you can see here is we've got 1, 2, and 3 columns, 3 separate plots, and it's plotted bill length on the x-axis, so using this dot map method. So this is quite a I like to create things in Python using these one-liners, using the dot methods. So in one line there, what I've done is created the facet grid, and then I've mapped histogram on top of it. So if this bit here from dot map onwards, if I hadn't included that and I just run the command SNS facet grid penguins and col equals island, what it would do is create three separate plots, but with no data plotted on them. So then we've used the dot map method to kind of overlay the data on top of that, to plot the data on that. So that's using columns. So you can see here we've got one row and 3 columns essentially, but you can also use a row argument. So I'm just going to do this. So this is the exact same syntax as above, but rather than using col equals island for columns, I'm using row equals island. And if I run that, you will see the difference between the two. Now we've got the plots are separated, island is separated over 3 rows, so we've got these plots stacked on top of each other. Okay, so takes up a bit more space though, so usually it's kind of easier to use the column, split things over columns like that if you've got a number of different categories that you're plotting. Okay, so like I said, all in one line here. We've used like a Python type of one-liner. One thing we can also do though, or another way we can do this, and it means kind of using more than one line of code, is we can use the facet grid argument, same as above, and set it equal to an object. So I basically just use sns.facetGrid penguins col equals island in the other syntax. But in this case, what I've done in this cell is I've set it equal to an object called BL, I think for bill length or something like that. And then in the second line of code, I've used bl.map. So I've created the object, and then I've used the .map method on the object. So if I run that, you will see it creates the same plot. So 2 ways to achieve the same thing essentially, and it depends what people prefer. Okay, so that's the .map method to overlay data, but there's another one you can use as well called map_dataframe. So I'm going to create a similar plot to the one above, but instead of bill length, I use a different variable. I use flipper length as the variable. So we're going to basically create a facet grid of 3 columns with flipper length measurements, plotted for each island separately. So I've called this object FL for flipper length, and that's I've created the facet grid, sns.facetGrid penguins column again is equal to island. This time I'm using FL, the data frame object, .map_dataframe, and then sns.hisplot, comma, and this time I've specified x equals flipper length in millimeters. Okay, so let me run that. It creates similar plots, but we've applied a different variable in this case. You will notice that above we didn't have to specify this x equals bill length in this case. That's because when you use this map method, it only takes this one positional argument and it will plot it on the x-axis. But you can use more than, when you use map_dataframe, you can create more than one. You can add more than one positional argument. And if I hadn't included x equals here, it would have kicked back an error message. So it would have asked for the sort of correct positional argument. One thing this means is you can kind of play around and change things using this data frame method. So instead of plotting this on the x-axis, saying put flipper length on the x-axis, we could have specified to put it on the y-axis. So this is same plots as above, but this time we're going to plot them on the y-axis. So there you can see the flipper length's now on the y-axis, count on the x-axis. Not sure you would particularly want your histogram plotted like that. Some people might prefer that, not too keen myself, but it just kind of illustrates the fact that you can do different things using the map data frame method when you're using facet grid. So where we have more than one positional argument, we can plot relationships. So we can use different types of plot other than just a histogram, so long as we supply the required positional arguments. So here what I'm going to do is I'm creating a data frame object called BL scat, so bill length scatter essentially. Creating the facet grid, penguins data frame again. We're going to put island as columns, so give us 3 separate plots. And I'm going to use the map underscore data frame method. And this time I'm specifying I want a scatter plot rather than a hist plot. And on the x-axis I want bill length, and on the y-axis I want bill depth. So if we run that, what that's done is created a relationship plot showing us the relationship between 2 scale variables, bill length and bill depth. And we can, by default, if you look, the axes are labeled here with the name of the variable as it appears in the data frame. So it's got these underscores as it's saved as a string in the data frame, and that's how it appears on these plots. But maybe we wanted to tidy that up because we want to edit that, so we can do that by setting axis labels. So what I've done here, these first 2 rows, these first 2 lines of code are exactly the same as the cell above we used to create this plot. And then what I'm doing is blscat.set underscore axis underscore labels. And then within the parentheses, I'm basically specifying the string that I want to appear as a label on the x-axis and on the y-axis. So you can see I've got rid of the underscores, I've got millimeters in brackets. So if we run that, you can see that kind of looks a bit tidier now. The axes are labeled a bit more nicely. And we can also edit the title for each column. So you can see here it's got island equals Torgerson, island equals Bisco, island equals Dream, and we can change that. So this is kind of building on the plot above. We're going to sort of amend the titles, and the titles above each column essentially is what we're going to look at. And I'm going to do that. To do that, I'm going to use blscat object.set underscore titles, and then I'm passing col underscore templates, and then as a string I'm passing col underscore name in curly brackets, and then just saying island essentially. So what this will give us, if we run that cell, you can see now it's got the kind of rid of the island equals, and it just says the name of the island. Okay, so it's looking a little bit more tidy, a little bit more professional if we wanted this for some sort of publication. And another thing we can also do is we can combine our separation of plots by different categories by using both column and row arguments. So far above we've either used column or specified we want to separate the island based on columns, or we did rows above there that gave us that really long stacked version of things. What we can do is get more granular, and we can separate the columns based on islands, say, and then the rows based on some other category. So that's what I'm going to do here. So these 3 lines of code are identical to the one we used above, but what I've done here is added this row equals species argument in the initial facet grid method call. So if I run that, what you will see is we've now got each column represents an island, and each row represents a species of penguin, and we've got 3. So this top row here, it represents Adelie penguins, the second chinstrap penguins, and the third row Gen 2 penguins. You can see Gen 2 all the way across. And if you look, some of the plots don't have any data on them, and that's obviously because, in the case of Torgerson Island, there are only Adelie penguins on that particular island there are no chin strap or Gen 2, and here on Dream Island we have no Gen 2 either. So yeah, pretty useful to be able to get more granular by creating this grid which breaks the data down by different categories. Let's try a slightly different one this time. This kind of might be a little bit better as a grid of plots. So rather than row equals species, let's put row equals sex, and that should kind of separate the data out by sex and by island. And we're still looking at bill length and bill depth are the two scale variables that are plotted, the relationship by plotting. So you can see this top row here relates to males, this bottom row here relates to females. Okay. Another thing that's worth looking at here is if you notice, so the y-axis scale currently only appears here on the far kind of side, on the very first, next to the very first plot. It isn't here, and it isn't here, and we can change this so we've got the scale on each of the plots by using this sharey or share y argument. Okay. The thing to note though is this can currently, whilst it's only on this one plot, the scale is the same for all three, and if you change it, that might change the scales on which each of the plots is measured on. It might if the data is better represented on a slide by rescaling, Seaborn will do that for you. So in this case, we'll see it doesn't make much of a difference, but it can. So it's worth kind of being aware of that. As it is currently, where they're all on the same size scale, you can see the relationship between them across plots. But if you weren't paying attention and changed, turned this share y argument off, setting it to false, as I'm going to do, you could find that the visual relationship is deceptive because they're measured on different scales, and you can see that a little bit here. The Bisco Island data is now scaled. It's not hugely different, but it's slightly different. And if you had considerable differences between categories in terms of measurements, you could give yourself the impression that there's the same range of scores here as there is here. Well, it's not necessarily true, because they're measured on different scales. So that's share y equals false. There's another kind of argument like this called share x, share the x-axis. You can set that to false as well. You would normally use that when to change sort of the x-axis, so it would put if you had multiple rows, so it would put bill length here as well, the scale under each plot individually. Okay. So as you've seen with previous plots I've created using, sorry, just a typo there, I'm going to change that. As you've seen in previous plots I've created using Seaborn, you have this hue argument which you can use to separate categories based on different colours. So let me run that here. What I'm going to do is I'm plotting a couple of. I'm going to use a scatter plot, and I am going to plot two different variables: flipper length and body mass. We're going to separate the columns based on island still, so we'll have three columns, one for each island. But we'll separate the color of the data points by species. If I run that there, we can see I've also added this I've called the data frame object mass, and I've also added this mass.add_legend. So it's put a legend next to the three plots. So you can see there what it's done is it's separated out based on color: green a Gen 2, orange a chin strap, blue or a deli. So we only get a deli on Torgerson. In terms of flipper length, you can see we've got this species difference in flipper length between Gentoo and Adelis on Bisco, and there seems to be Adeli and Chimstrap seem to be kind of similar size in terms of body mass and flipper length. One thing to note here is that this hue argument goes up here in the initial facet grid call. If we'd have put it down here, say under the kind of map data frame arguments, those extra things were blown on top, it might have created errors for us in terms of it might not have identified, because we've got different numbers, we've not got all three categories on these plots, the colours, it might have duplicated the colours for different categories on different plots. So we might find that, you know, blue was Adeli on the first plot, but blue was Gentoo maybe on the second plot, something like that, or whichever was missing. Okay, so just something to keep in mind there. Being able to use colours to separate out groups is pretty useful for these plots, but it needs to, the hue argument in this case with the facet grid needs to go in this initial line of code. Right, so one last thing. So far we've just looked at scatter plots and histograms. I'm going to create one last plot, but this time rather than a histogram or scatter plot, I'm going to use a KDE plot, and just to visualize the distribution of one variable, so the x variable. I'm using the map data frame method, and I'm going to specify body mass in grams. I've added a couple of extra arguments here. We're going to set in the line width for the KDE plot, that continuous distribution curve. I'm setting fill equal to true. So we'll get three plots, one for each species on the columns, and the rows will be separated out by sex, male and female. Let's run that. So there you go. So what we're getting is this first column here is Adeli's, the top plot is males, the bottom is females. Here we've got chin strap, top plot male, bottom is female. And then the third column here is Gentoo, top plot male, bottom plot female. So you can see there's some sexual dimorphism between males and females in penguins. Males appearing generally to be heavier than females. So I thought I'd end with a KDE plot because they're one of my favourite types of plots for representing distributions of data. Okay, so that is seaborn facet grid, a really useful and kind of easy to use method for creating these small multiples where we're kind of splitting data, grouped data across individual plots, putting them side by side so we can make some sort of visual comparison. There are lots of other options for styling and for aesthetics and things like that, and as I've said in previous videos, look at the seaborn documentation or the matplotlib documentation online, and you can see all the different parameters and arguments you can use to change these things about. Okay,